Hi everyone, welcome back to Big Brain Academy USA. This high school video we are going to be working on solving unknown variables for the Big Brain. What is a variable? This is an algebraic topic, and in algebra you commonly come across algebraic equations. And in those algebraic equations, sometimes you know all the numbers and sometimes you don't. The numbers that you don't know are represented by symbols called variables. The exact definition of a variable is a letter that stands for numbers that we don't know yet. So an algebraic equation has many parts, and here we're going to be looking at two of them, a variable and a constant. Right here we have this algebraic equation, 9x plus 5 equals 54. So we just learned what a variable is, a letter representing unknown number values, but we are still yet to know what a constant is. The exact definition of a constant is a number on its own with a value that does not change. Now let's identify which one a variable is and which one a constant is. Well, the variable is very easy because it's a letter representing unknown number values, and the only letter we have here is the letter x. What about the constant? It has to be a number on its own, so it definitely can't be the number 9, because the number 9 is a coefficient. A coefficient is the number right in front of the variable. So that's together with the variable x, it's not on its own. So 9 is not our constant. It's either 5 or 54. Well, 54 is the answer to our equation, and that's not our constant because it could change. If we change any other component of the equation, then the number 54 could either increase or decrease. So the only number remaining is 5, which actually is our constant because it's on its own and it will not change. In order to get our x by itself or any variable by itself, the technique used behind it is called isolating the variable. Let's look at the general outline of the steps. First, you would use the distributive property to remove any parentheses. Then, you would combine like terms. The purpose of doing these two steps first is to get it as simplest as we can before we start doing our inverse operations. Once we start doing our inverse operations, we would have to first add or subtract to get variables to one side and constants to the other. And then we would finish off by doing multiplication or division to get the variable completely by itself. A little note about combining like terms is that combining like terms is really simple. It's just getting together all the numbers that have the same variables and the same exponents. Let's just go into a little brief review about our inverses. We should already know this. The inverse of addition is subtraction. Inverse of multiplication is division. Inverse of an exponent, something to the power of something else. The inverse of that is radical. Two more specific examples that you should be more familiar with is the square of something. When you do something to the power of 2, the opposite of that is square rooting it. For cubing something to the power of 3, the opposite of that is cube rooting. Now let's look at some examples. We have the steps to the side to make it easier for us. First, do we have any parentheses here? Yes, we do. We have 2 parentheses x plus 3 parentheses equals 40. That means we would definitely do the distributive property first. And as the distributive property says, we do everything outside of the parentheses multiplied by everything inside. So here we would do 2 times x and 2 times 3. That gives us 2x plus 6 equals 40. Now we combine like terms if there are any. Are there like terms here? No. Now we begin to do the inverse. So what operations do we have here? Well, 2 is being multiplied by x and 6 is being added to 2x. So we have multiplication and addition. And on our steps, we have that we do addition before multiplication or division. So the opposite of addition is subtraction. So now we do minus 6, and plus 6 and minus 6 cancel out. And that leaves us with 2x equals 34. So 2 is being multiplied by x now. Multiplication is the only operation we have left, so we can just do the inverse of that. Let's divide everything by 2. The 2 cancels out, and we get x equals 17 as our final answer. Another example we have is 15y minus 15 equals 20 plus 10. So, do we have any parentheses here to do the distributive property? No. Can we combine like terms? Yeah. We have 20 and 10 on the right side of the equation, and we could just circle those and combine those because they're both alike. That gives us 15y minus 15 equals 30. Now we have to do the inverse operations. What operations are there here? Well, there's multiplication with 15y, and there's subtraction, minus 15. So let's do the inverse of subtraction first. We add 15 on both sides. Cancel that out, and we get left with 15y equals 45. Now we do the inverse of multiplication of 15. We do divided by 15 on both sides. 45 divided by 15. Our final answer is y equals 3. So that's it. I hope that was helpful. And if you want more help, join us twice every week for a new video to help you become Big Brain. Come say hi to us on our Instagram at Big Brain Academy. And don't forget to like, comment, and subscribe to our channel. Thanks for watching.